In this video, we'll learn about Vertipaq table matrix. So we need to know what are the table statistics before doing the actual optimization. So here you can see this is the demo data that we have connected with the Power BI desktop, and these are different tables, and this one is the diagram. So we need to open the DAX Studio, and then we need to choose PBI, connect. And here you can see these are the local date table that we can hide. And if you click here, advanced, and click on the export view matrix. So here you can see we have different tables like customer, sales, sale order, date, and a lot of other tables. And the first column is the cardinality. So what is the cardinality? This is the total number of available values in the table. For example, in the customer table we have 18,484, and for the sale is 60,398. And we can also verify these numbers. Just need to go to the Power BI desktop, and here I had already written one measure. For example, customer count. So here you can see the customer count is equal to count row, and we are providing here the customer table, and you can see 18,484, and the same you can see here 18,484 and 60,398 for the sales, this one, right? Here we can see for the customer the cardinality is 18,000, and for the sale it is 60,000, and then you can see here different like powder color, dim powder subcategory. Objective is to minimize the cardinality to increase the performance. And then the second column is the table size. So here you can see that for the customer we have 2.5 million. For the sales we have 2.1 million, and for the sales we have 2 million. And here you can see the cardinality here is 60,000, and for the customer the cardinality is 18,000. But if you see the table size for the customer table is greater than the sales table, right? So that we need to investigate why this thing is happening and how we can minimize the table size. And in the same way you can see the table size for the other tables, because we should know in advance all these statistics before we can do the actual optimization. And then the next column is the column size, and here you can see the column size is greater than the table size for example for the customer. And how column size is calculated: if I expand customer, and here you can see the column size is the sum of all the columns like a name, address, line 1, birthday, and then they are summing up, and we are getting this size. Here you can see the column size is greater than the table size. Why this thing is happening? Because the column size is consist of data dictionary, data dictionary, and hierarchy size plus the relationship size. If we combine data dictionary, data, and hierarchy size, then the total of these three columns will be equal to table size. But we are getting the column size a little bit higher because of the relationship size, this one. And if we look, for example, dates, where the relationship size is 0, and if you look here, the column size and the table size both are same. And always remember one thing, the relationship size will always be on the many side. For example, if you look at the customer, normally customer is a dimension, but the customer will be on the many side. We can verify this thing. Just go to the Power BI desktop, go to the model, and here you can see um, the parent table is the territory, and then the child table is customer. The customer table is on the many side. So that's why the customer table is showing the relationship size, because the table that is on the many side, that table will define the relationship size. And in the same way, if you look here, for example, date table. So here you can see the date table is on the one side. That's why we are uh, that's why there is no relationship size, or the relationship size is 0. And on the other hand, if you look at the sale order, we will find some relationship size on the sale order table that we can look here. For example, we can go to the DAX Studio, and let's have a look to the sales order. So here you can see the relationship size is 3896. So that's all about column size, data dictionary, and hierarchy size. The hierarchy size is automatically defined by the Power BI. And here you can see the next column is the encoding. In the last video, we have seen different compression techniques, and here you can see everywhere we are seeing many. So why this thing is showing here? If we expand, for example, customer table, and here you can see we have different compression methods applied here. Some are hash, value, and so the overall aggregation will be some many, because they are using more than one compression method. In the later video, we will see why hash or value is being used for these columns, and then we will see how we can change these compression methods according to our choice. And then this is the data type, and then we have the RI violations, referential integrity. So here you can see, for example, this one, territory, we have the referential integrity. So why it is showing us 1? Because let me show you the diagram here. So this is the parent table, and this one is the child table. So the territory table is showing referential integrity. The reason is, if we have values available, for example, these two tables are connected with each other by using a geographic key. So these two tables are interconnected with the geographic key. So it means the geographic key is available in the customer table, but not available in the territory table. If the child table contain keys that are not available in the parent table, then it will cause the referential integrity that we need to fix. And in the later videos, we will see how we can fix the referential integrity. And this is the user hierarchy size and the relationship size that we have already discussed. And this is the table percentage, and it is also because we are at the table level, and that's why it's empty and it's like 100%. And then we have the dB percentage. So here you can see we have different tables here, and then we need to know that the percentage of each table. If we take all the tables into consideration, then we need to know that which table have the bigger impact. The customer table is taking 24.55%, and the sale table is taking 19.27%. And then we can drill down directly those tables that are taking much more memory. So, and the next column is segment partition that we will see in the upcoming videos. And the last column is the number of columns available in each table. For example, the customer table contains 17 columns, and the sales table contains 20 columns, and so on. So these statistics are very, very important so that we can do the optimization accordingly. So that's all about this video. So if you have any question, please write in the comment section, and if you like this video, please subscribe our channel. Thank you.